All right, so we're moving on to the next lesson, which is graphing linear equations. We started this a little bit yesterday, but we mostly focused on solving for y or getting the equations in function form. So we're going to talk a little bit more about that today. So when we're talking about graphing linear equations in a coordinate plane, a solution of an equation in two variables, so there's an x and a y variable, you will have a solution that looks like an ordered pair. That ordered pair is going to contain an x value and a y value that will produce a true statement when the values of x and y are substituted into the equation. And the graph of an equation in two variables would be the set of all of the points in the coordinate plane that contain all of the solutions of the equation. And of course, a linear equation would then graph a line. Now, there is the standard form of the linear equation, which consists of ax plus by equals c, where a, b, and c are real numbers, and a and b are both not zero. The equation represents a linear function, provided that b is not zero, because then it would be a vertical line, which is undefined. So if you were to get a question, such as this one here, on a test or a quiz or something like that, the easiest way to do this would be to test the points. So simply by substituting in the x's and then the y's and seeing if it produces a true statement. Now this particular question, if I substitute in example A, -2 for my x and 4 for my y, when I multiply these two, I get -1 plus 4, which does equal 3. Now, if this were a multiple choice question, I would be done there, assuming that I did that correctly. But just to show you what would happen if maybe it didn't work, if you put in example B, where you have a 2 and then a 3, half of 2 is 1, and 1 plus 3 is 4, and that does not equal 3, so then like this would not be a solution. So let's check these three examples here. So if I'm going to check number 1, I want to put the 2 in for my x, and I'm going to put this -1 in for the y. So I would then have -2 times 2 plus 3 times -1, and hopefully that will equal -7. So -2 times 2 is -4, 3 times -1 is -3, and that does equal -7. So yes, the point or the ordered pair 2, -1 would be a solution to that equation. Now, if we look at the next example, this is a little bit different because we have x equals -3 as our equation here. Now, in this particular equation, we only have an x variable. So if I were to plug in the x variable here, which is 0, it says 0 equals -3, which of course is not true. So no, this would not be a solution. But alternatively, you could even just look at the point. Whenever you have an equation that just says x equals a number, then your x value would have to be that number. But in this case, the -3 is the y value, not the x. And then finally, the third example. So if I'm going to put in my 9 for the x, and then I'll put in my 2 for this y. So we have 2/3 times 9 minus 2, and hopefully that equals 4. Well, the 3 and the 9 can cross cancel or reduce, leaving me 6 minus 2. And of course, 6 minus 2 does equal 4. So yes, this would be a solution as well. So now that we understand how the ordered pairs are representing solutions, obviously there can be many, many solutions for a variable that has two, for an equation that has the two variables, the x and the y. Now, when we're going to graph it, the first thing we want to do is solve the equation for y, and we also call this getting it into function form. So if I take my equation, 3y equals x minus 3, I want to get this y by itself. Now, in this case, I only have the 3y on that left side, so all I would have to do is divide by 3, and of course, everything would need to be divided by the 3. Leaving me with a y that's all by itself. And then this x divided by 3, remember there's really a coefficient of a 1 there, that implied coefficient. So this is 1/3 x, and then 3 divided by 3 would be 1. So this is now my equation in function form. Now, the reason we do that is because then when we want to fill a table of values in, it's much easier to substitute in. Oops. It's much easier to substitute in for x when the y is by itself, because it's much easier to solve for the y if everything else is on the other side of the equal sign. So here is the domain that we're going to use. So the domain, remember, is all the input values or what you're substituting in for x. So if you have it set up in function form, most likely you'd be able to do these in your head, and it would be pretty straightforward. So 1/3 times -6 minus 1. So 1/3 of 6. Now the reason I picked this domain is because all of these values are multiples of 3. So when I multiply them by the 1/3, I will be left with an integer. So this is -3. Now if I do 1/3 times -3, the 3's cancel, so I have -1 minus 1, which is -2. Of course, if I do 1/3 times 0, that all cancels out, and I'm just left with my -1. 1/3 times +3, the 3's cancel. 1 minus 1 is 0. And 1/3 times 6, the 6 and the 3 reduce, and I have 2 minus 1, which is 1. So then the third step would be to plot those points on your graph, and hopefully they'll make a line. So -6, -3, -3, -2, 0, -1, 3, 0, and 6, 1. And then I can draw a line through those points. Now in this particular example, if we were talking about domain and range, remember domain is those x values, and then range would be your y values. Now in this particular example, notice that there was no restriction given to me about what I could put in for my x. So when that happens, it's simply just going to be all real numbers. And notice that there was positives, there's negatives, a 0. I could have inputted fractions or decimals if I wanted to. It would have made it a little bit harder, but I could have still done it. And also, if you look at the graph, the x's, or the graph itself, is spanning left to right in both directions to infinity. Now, the range is your y values. We got all kinds of y values for our answers, negatives, positives, 0, whatnot. If we had plugged in some other numbers, we would have probably got some fractions or decimals. But if you look as the graph's tilting upwards and downwards, it is continuing on and on towards both directions, towards infinity. So the range here would also be all real numbers. And most linear equations are going to have this domain and range because there's never a restriction on your domain, and therefore there would be no restriction on your range, provided there's not a restriction given to you. So there are some situations that might represent a real life scenario where there would be a restriction. So for example, if my x's were representing something like some kind of an object or maybe time or something like that, well, you can't have like negative objects or something like that. And you can't necessarily have negative hours. So then there would be a restriction on that domain. And then once you have a restriction on your domain, there then translates into a restriction on your range. So then your domain and range won't be all real numbers, and we'll see that in the next example. Okay, so let's take a look at the next example. Now this time, we're going to graph this function here. It's already set up for us in function form, which is kind of nice. The y is already by itself, but this time they're giving us a domain restriction. Okay, so a lot of times it'll be written as an inequality. If it's written as an inequality, that's just telling you that x can be something in between -1 and 4. So x is greater than or equal to -1, meaning that -1 is the smallest number x could be, and x is less than or equal to 4, meaning 4 is the largest number x could be. So that means your domain is all of the numbers in between and including -1 and 4. Now, it could be decimals, it could be fractions, it could be positives and negatives that are in between there. but you can pick anything within that domain to make your table. Now, it's easiest if you just pick integers for the most part, because they're going to be a lot easier to substitute in. Like, why would I want to pick a fraction or a decimal if I didn't need to, right? So I'm going to start with the -1, and then I'm just going to go up 0, 1, 2, 3, and 4. And of course, all the fractions and decimals in between those numbers would be included on our graph anyway. So since my equation is simply just -x plus 3, I can pretty much plug most of these numbers in my head and get my y values. So -1 would make that a positive, and a +1 plus 3 would be 4. 0 plus 3 would be 3. -1 plus 3 would be 2. -2 plus 3 is 1. And then we have a 0 and a -1 to finish it out. So then I would want to graph the points that I did get. Now keep in mind, since I do have a domain restriction here, I'm going to highlight that on my x-axis. My domain restriction was from -1 to +4. So that means my graph cannot exceed or pass those two spots on the x-axis. So when I plot my first point, -1, 4, notice I'm right at the end there. Then 0, 3, 1, 2, 2, 1, 3, 0, 4, -1. Now, normally we would draw a line with arrows on the end, but because we have this restriction, I can only go from this point to this point, and I would have to stop, making it a line segment. So now we can see that the x value here, this domain, stopped at -1, and then the graph stopped here at the 4. But let's look at the range. So the range would be your y. So it goes down here, and all the way up to here, there's some y values using these. So that would mean that my range in this case, which is my y values, right? The y's are between the bottom or the lower value here of -1 and the higher value here of 4. Just so happen that they're the same values that we had on the domain. And of course, the symbols have to be opening up towards the number on the right, because that's the bigger number. So -1 is less than or equal to y, which is less than or equal to 4. That just means y has to be a value between those two numbers. All right, so let's try that again. Now in this example, we're going to have to solve for the y first. So I'm going to write it over here, 4x minus 2y equals 2. Now first thing we want to do is get the entire y term alone. So I'm going to leave all of that at -2y, and I'm going to move my 4x over using the inverse operation of minus 4x. So I have -2y equals -4x plus 2. Then simply dividing everything by -2, that will leave me with y equals 2x minus 1. Now, there was no restriction given to us in this particular problem. So when I go to make my table, I can put any values I want in for x. Now, if there's no restriction and there's no fraction in my equation, I generally go -2, -1, 0, 1, and 2. They're the smallest numbers. They're pretty much the easiest numbers, and they're most likely to fit on your graph. So I'm just substituting these in here for my x. So 2 times -2 is -4, minus 1 would give me -5. 2 times -1 is -2, minus 1 is -3. 2 times 0 is 0, then I have the -1. Then 2 minus 1 is 1, and 4 minus 1 is 3. So plotting those points, -2, -5, -1, -3, 0, -1, 1, 1, and 2, 3. Now this time we are going to draw our line through the points with the arrows on the end, because our domain was all real numbers since there was no restriction. And our range would also be all real numbers since there was no restriction on our domain. So let's try number 5. All right, so this time, here's our function, y equals 1/2 x minus 5, but this time we have a domain restriction. Now, the nice thing about this one is it's already in function form. So that's going to make it a little bit easier for us to get our numbers here. However, let's look at this domain restriction. So this domain restriction is saying that x is greater than or equal to 4. Now, I like to highlight the restriction on the x-axis. So I know that all my x values have to be equal to or greater than 4. So I know I can only pick x values in this realm here. Now I'm going to start out with the 4. Now I could pick 5, 6, 7, 8, 9 if I'd like to. But what I'm going to do, since I'm going to be multiplying whatever x values I pick to 1/2, I want them to be even numbers so that when I multiply them to the 1/2, I'm left with an integer and not a fraction. So if I want to pick 4, 6, and 8, for example, then I'll pick 10. Oops. And I could pick 12, but that won't fit on the graph. So I'm just going to pick those 4. Now, if you do pick 5, 7, or 9, you'll still get an answer, but it'll be a fractional answer. So now I'm going to substitute these in. Half of 4 is 2. 2 minus 5, negative 3. Half of 6 is 3. 3 minus 5 is negative 2. Half of 8 is 4. 4 minus 5, negative 1. Half of 10 is 5. 5 minus 5 is 0. Now, if you did pick, just to put it on there, in case anybody would do this, 5, 7, or 9, you would have ended up with negative 2.5, negative 1.5, and negative 1/2. Or you could have had those as decimals as well. But you can see it's going to be just easier to keep the numbers that will work out evenly. Okay, so plotting these, so 4 and negative 3, 6 and negative 2, 8 and negative 1, and then 10 and 0 would be right there. Now, if you did do the 5, 7, 9, you would have negative 2.5, negative 1.5, and negative 1/2. So you can see they're still in line. Now, because I can't go beyond the 4, I can't go left of the 4 since I'm restricted there, I can't go through this point. I have to start at this point here and just go towards the right. So my arrow is only going to go in one direction. Now with that, I might want to find my my range. So I'm going to look at my y values and notice that the lowest point here is at this negative 3, and then it's kind of going upward, right? There's no restriction as I go upward. So my range here would be that all my y values are greater than or equal to negative 3. Okay, so that is it for the notes, but then we did do a little bit of practice with a worksheet. Okay, so deciding which of the 2 points lies on the line of the graph. So all you'd be doing is substituting these values in here for x and y and deciding whether or not it works. So for the first one, 2 times 4 is 8. 8 minus 3 does not equal 30, so that would not be a solution. Oops. But then if we plug it in the next one, 2 times 24 minus 18 does equal 30, so that one is a solution. Trying example 2. So for this one, if I do negative 9 minus 3 times 1, I do get negative 12. So negative 9 minus 3 equals negative 12. So that one is a solution. If I try the next one, I'm going to have negative 6 minus 66, and that definitely does not equal negative 12. So A would be the answer there. And then for C, now be careful with C because the X is actually over here, and the Y is the one next to the 2. But on first glance, you might be on habit of putting the X first and then the Y second, so just be really careful. So if I do the first option, I'm actually putting the 1 in here for my y, and then I'm subtracting 5. So this gives me 2 minus 5, which is negative 3, and that does not equal 9. But if I do the other example, if I do B, then I'm going to do 2 times 5 minus 1, and that's 10 minus 1, which does equal 9, so that would be my solution there. So just be really careful about plugging in your x and your y. They don't have to be in any special location. You just have to make sure you're plugging into the right one. So solving for y, I think it's really important that we go over this part because this is typically where the mistakes happen. Most people are pretty good at plotting points or even plugging in and getting the points. It's just getting the y by itself that can be an area for errors to be made. So in this particular problem here, the y does not have any coefficient. It's positive. So all I need to do is bring my x term to the other side. So now my y is alone, and of course 6x and 11 are not like terms, so they cannot be combined, and that is your equation in function form. If you go to the next one, again, we want to get the y term by itself first. So first we move the x term to the other side. This leaves my 2y by itself, and then I have negative 8x plus 10 on the other side. Again, they're not like terms, so I can't actually add or subtract them. Now I divide everything by 2 to get the y completely alone. I have y equals negative 4x plus 5. Okay, number 6, my y term is negative 3y. So be really careful because there's a negative on there. So first I'm bringing my x term to the other side by subtracting 6x. Now I still have a negative 3 in front of my y. And on the other side I have negative 6x plus 29. Now I'm going to divide everything by negative 3, leaving me with y equals 2x minus, unfortunately 29 does not divide by 3 evenly, so I'm going to leave that as a simplified improper fraction. Okay, next one here. I've got my 2y that I need to get isolated first, so I'm going to add my 4x over to the other side. I now have 2y equals 4x plus 16, dividing everything by 2. So y equals 2x plus 8. Okay, next one. This is another negative y term, so be careful with that. First, we're going to subtract over the 10x. Negative 5y is still left on the left, and then we have negative 10x plus 25. Remember, they're not like terms, so I could not add or subtract them. But I can divide everything by negative 5. Now, be careful with your signs here. You have a negative 10 being divided by negative 5. Just going to make that a positive 2x. And 25 divided by negative 5 will give you a negative 5 there. Okay, and then number 9, this is a positive 2y that we're going to get by itself. We're going to move that 3x over. So we have 2y equals negative 3x minus 8. Divide everything by 2. Y equals negative 3 over 2x. Leave it as an improper fraction. Do not change it to a decimal. Minus 4. Okay, so continuing on with this little bit of graphing here. Again, you want to really just keep getting those y's alone. So for this one, I'm going to end up with y equals negative x plus 14. And at this point, you could make a little table. I wouldn't stress too much, just maybe try, always want to use 0. And in this case, since the x-axis is going by 4s, I'd probably do positive 4 and negative 4. So if I put those numbers in here for x, well, the 0 is going to just give me that 14. Negative 4 plus 14 would give me 10. And negative 4, that's actually going to become a positive, so it'd be 18. And this one would give me the 10. So negative 4 and 18. Now this is going 4, 8, 12, 16, 18 would be about halfway up there. Then 0, and then 4, 8, 12, 14. And then 4, 10. So 4, 8, and 10. And there is no restriction, so my line's going to go with arrows on both sides. This one here, we just have to move that 5x over. So y equals 5x plus 2. They're unlike terms, so I cannot combine them. Okay, this time my grid is going by 2s, so I'm going to do -2, 0, and +2. Putting in the 0 is always my favorite to do first because it cancels out that x term, and I'm left with a 2 there. 5 times 2 is 10, plus 2 would be 12. 5 times -2 is -10, plus 2 would be -8. So -2 and -2, 4, 6, 8 is actually going to be slightly off the graph. Then 0, 2, and then 2, 12, 2, 4, 6, 8, 10, and 12 would be off the graph too. If you had done ones, you would have gotten fractions in between here. I'm just going to, and then your arrows on both sides. Okay, so I'm going to move down to number 13 because I want to make sure we look at a problem like this. So when you have an equation that's just x equals a number, you really should just remember or try to memorize that this is going to be a vertical line, okay? And it's always going to go through x equals -6, okay? So think about this for a minute. What does this mean? If x equals -6, that means every point on this line is going to have an x value of -6. So you can put any y values you want in there. I can do -4, I can do 0, I can do +2, +4. -6, -4, -6, 0, -6, 2, -6, +4. Notice that they start in a vertical line starts to emerge there. So basically, you're just going to find this x-intercept, the x equals -6. You're going to find that, and then you're going to draw a vertical line intersecting the x-axis. You're going to do the exact opposite if you get a question like number 14. So number 14, we have y equals a number. So this one is going to be a horizontal line. And it's going to go through y equals 4. So you find the 4 on the y-axis, and you would draw a horizontal line through it. Now, it makes sense because every point on this line has a y value of 4. So pick a couple random x values that would fit. So maybe like a -1, -4, I'm going to pick 0 and 2. So -4, 4 would be here. 0, 4 is the one that we plotted, and then 2, 4. And notice that that horizontal line starts to emerge. Okay, so let's do one of those that has a restriction this time. So if we take a look at number 19, y equals -1, and then there's also a domain. So remember, when there's a domain, it's a nice idea if you have a highlighter or something to highlight where that domain is going to be. So if my domain, my x values have to be greater than or equal to -1, I'm going to highlight the numbers on the x-axis that are greater than or equal to -1. So I know I can't go past there. Now, this particular equation, y equals -1, means that all of my y values on every point there are going to be -1. So I can pick any numbers I want for my x's. So if I do -3, -1, if I do 0, -1, 3, -1, whatever. However, in this particular case, there was a restriction. So this would not be a choice. I would have to do values that are greater than or equal to -1. So I'm going to keep my -1 as my lowest point. I'm going to have this one as well. So we wouldn't do that. So this is our line. And notice it's a horizontal line, but it's starting at that one point where the restriction was in place. Now my range is all the y values. Well, all of the y values have to be, what? If this is a y equals -1, then we know all the y values are -1. So they're basically giving you the range here. Just like in an x equals equation, they're giving you the domain. There's only one possible x value that you can have. Okay. So trying this one here, number 18. Here's my restriction. X is less than or equal to 2, so that would be this part of the graph. And I already know my range, obviously, is y equals 3. So in this case, I'm going to plot the 3 on there, and then I would draw a horizontal line through it. However, I know I can only go up to this point, so it's going to go that way. And if it's easier, I think it sometimes helps me out a little bit to get some random points. So I knew that x was less than or equal to 2. So I know that was my lowest x value. So I'm going to just do 2, 0, and negative 2, let's say. And then all the y's were 3. So 2, 3, 0, 3, negative 2, 3. And then you can see a line emerge there. And you know that you can't go past that highlighted area because that's showing you that is your domain restriction. Okay, so now in this case, we would be doing it without the graph. So again, it's always easiest to me to get that y by itself. So I would subtract the x. So I have 3y equals negative x minus 8. Divide everything by 3. So I have y equals negative 1/3 x minus 8/3. Not excited about these fractions, but it is what it is. Now my domain is x is greater than 0. So that means 0 is kind of like, it can't equal that, but whatever you get when you plug the 0 in, that corresponding y value, that's going to be like your cutoff point. So it won't equal that number, but you know that it'll be greater than or less than or whatever. So I'm going to start with 0, and then I'll put in 1, 2, and 3. So if I put a 0 in here, I'm left with a negative 8/3, which is actually negative 2 and 2/3. Might be easier to think of it that way. If you put in a 1, then you have negative 1/3, negative 8/3, which is negative 9/3, which is negative 3. If you put in a 2, you would get negative 10/3, which is negative 3 and 1/3. And if you put in a 3, you end up with negative 11/3, which is negative 3 and 2/3. Okay, so looking at our range now, that's our y. So our y's are all, notice they're getting smaller than the negative 2 and 2/3. And I didn't put the equal to under there because my domain restriction was just a greater than 0. So I know this is my cutoff, but I can't actually equal those numbers. Okay, so if we're doing a word problem, a bicycle rental shop rents bicycles for $8 per hour. The total cost in dollars for renting a bicycle for 8 hours is given by this function here. So we have C equals 8H, and it's $8 times the number of hours. Now this basically means that this H value is kind of going to be like my X in my table, and the C is like my Y, right? Now, most real life problems have some kind of a domain restriction because in real life, things can't always be negative numbers or, decimals or fractions or whatever. So once you get to rent the bicycle, at most 5 hours, and even though it's not telling us, okay, so H is my domain, so we know it's at most 5 hours, which means the H, the number of hours, has to be less than or equal to 5. But it can't just be anything less than 5. Like, can you rent something for negative hours? No. So then your lower number here would be 0. And again, you're not going to rent it for 0 hours. So I would just make this an H is greater than, but you're still going to, plot it at that point and everything. We're not going to get too much into the exact details there for now. Okay. So putting in those numbers 0, 1, 2, 3, 4, and 5 into this equation. So 8 times 0 is 0. 8 times 1 is 8. 8 times 2 is 16. Then we have 24, 32, and 40. So if we're to plot all of these, 0, 0, 1, 8, 2, 16, 3, 24, 4, 32, and 5, 40. Now again, it can't go past the 0 and it can't go past the 5 because you are limited to 5 hours at most. So that's why, again, we have a line segment here without any arrows at the end. What is the most you will end up paying? Well, that would be the $40 for the 5 hours. And then the range, of course, since your hours were limited, then your cost is also limited. The cheapest you could get it for is $0, right? And the most you could get it for would be, or pay, is $40. So if you went 0 hours, it'd be $0. If you went 5 hours, it'd be $40. Okay, a gardener at a nursery is filling pots with soil to prepare to transplant seedlings into these larger pots. Each new pot needs about 27 cubic inches of soil. The amount of soil in cubic soil inches, in 4,000 cubic soil inches, I'm not sure if that's what that means. Okay, it takes to fill pea pots is given by this function here. So very similar to the last one. So we have S equals 27P. All right, so the gardener is filling the pots from a bag of soil that contains 3456 cubic. So that is basically the most. So they're telling you the S has to be less than or equal to 3456. So they're actually giving you a limit on the range here. So if we know that the S can't be more than that, then what is the maximum value for the P? So I would have to take my 3456 and divide it by 27. So 3456 divided by 27. And that's telling me 128. So my domain here would have to be, the p-value would have to be less than or equal to 128. Okay, now that's helpful because now I'm going to make my input-output table. And I can start with 0, but I know that I'm going to go up to 128. Now, I probably don't want to do 1, 2, 3, 4, 5. I'll be here all day. So I'm looking on this graph that's already done for me, and I'm just going to pick the numbers that are already labeled on there because it would make it look a little bit easier. So now on my calculator, I would multiply each of these values. So 27 times 0 is 0. 40 times 27 is 1080. So that's how much soil you would need there. Then 27 times 80 is 2160. 120 times 27, 3240. And then, of course, we know this one is that max value of 3456. So now we want to graph this. So 0, 0, 40 and 1080, 80 and 2160, 120 and 3240, and then the 128 and 34 would be like a little bit past it. And we know that it stops there. Okay, then it said identify the domain and the range, which we did already over here, but we didn't put in the zeros, which we would have to do because you can't have a negative soil or a negative number of pots. So that's our domain and our range. Suppose the gardener needs to fill at most 100 pots. So we're now changing the domain to stop at 100. So then if we put the 100 in here, what do we get? 2700. So now our new range would go from 0 to 2700. That's it.